Our parachute project was trying to address a problem encountered when inexperienced skydivers want to practice flaring or pulling up on the parachute before landing. We wanted to design a system that would allow skydivers to safely practice without having to jump off an airplane.
Daniel Hernandez. Phil Thomas. He is like the Daniel who?
Daniel Trejo.
Daniel Trejo.
Juan Ramirez.
Juan Ramirez, yes. I'm Desiree Rose.
The cable we used was a 5/16 gauge galvanized steel cable, which has a breaking strength of 9,800 pounds. For this project, we used expansion bolts to anchor the cable to the rock. Otherwise known as sleeve anchors, they are made of 4 different parts. The stud, which is threaded and flared or cone-shaped at one end, the expander sleeve, and the nut and washer. The expander sleeve is assembled over the stud with the nut and washer threaded on the opposite side of the cone-shaped end. The sleeve anchor is inserted into a hole drilled in the base material, either concrete, brick, or block. The nut is turned, which pulls the stud up through the expander sleeve, expanding it up against the inside wall of the base material. The hole size to be drilled into concrete for a sleeve anchor is equal to the diameter of the anchor being used. We also used trolley pulleys, a harness, and 12 drop forged steel U-bolts. The correct method for attaching the U-bolts to the cable is shown here. For the first test, we loaded a bag full of rocks to ensure that the system that we set up was safe to use. Then we made a second run with an actual person. The final test run was done with person and parachute. You can see from the footage that although the parachute did begin to expand, we weren't able to reach maximum velocity in order for this experiment to take flight. Here are our calculations. And here are the SolidWorks models of some of the parts we used. As you can imagine, a project of this magnitude is not cheap. Here is our materials list.